Hi, so I want to get started on the second practice test. I'm just going to make sure I've got some solutions for you. So we're asking for the forces on the box, and it's raised at constant speed. And let's be absolutely clear. This part here on the right is not a force on the box. That is a distractor. So this is not in the free body diagram at all. So the only set of forces you draw on this box will be the tension going directly up from the rope and the weight or the force of gravity going directly down. All right. Now we have forces going on this box, forces acting on this box as it moves to the left at constant speed. Let's be clear. So we're going to have a normal force pointing up from the surface of the table. We have the weight of the box. Now, clearly we have a force from the hand. You can call that a pushing force or a hand force. Now, if we only had this force, the object would be moving and actually gaining speed. But since we know we're moving at constant speed, there must be a counteracting friction force to balance it. Now, block A pulled down or pulled across a frictionless table, we're going to have the normal force, the weight force or the force of gravity, and then we're going to have what we call a tension force from the rope moving to the right. Then number 4, just to be clear, the normal force on this block goes perpendicular to the surface. Okay, it should actually form a right angle. Okay, so that's the force from the inclined plane. We have the weight of the block going down, and then we have a rope force going up the inclined plane like this. And we got to be really clear, these need to be at right angles if you draw these, and this needs to be perpendicular to the line of the surface. Those are all really important things. Okay. Now, here the boy is pushing down on the wagon, and the wagon is moving at constant speed. So we're going to have a normal force, a weight force. Always we have those. Now the kid pushing down on the wagon, it's really tempting to draw the arrow like that, but we always draw forces going out of the object, so that needs to be moved here. And that's the kid pushing. Now if these are the only forces we had, the wagon would be moving and gaining speed, so we have to have a friction force going back the other way to balance that so that it moves at constant speed. Because if we didn't have that friction force, the forces would be unbalanced to the left. All right, block B falls. Don't get confused about what's going on here. This is block B, by the way. We're going to have the tension going up and the weight going down. All right, so I don't know why that skier is there. It's weird, okay? Just a little typo. All right. So that is the first 6 problems, and we'll take a look at the second 12 problems in the next video.